All right, hi everybody. A couple of you got to listen to me troubleshooting here as I was kicking everything off. I just had a couple of issues with not uh, enjoying the UI and the aesthetics I was getting as I was trying to share my PowerPoint with everybody. It is 1 o'clock. I am going to get started. We had lighter registration for this one, I imagine, just because of the timing of the holidays and everything than what we had for most of our webinars this year. And this is the last one of our Webinar Wednesday series. Plan moving into next year is going to be to shift the format a little bit, where we're still going to be doing these things. I'll still be putting together these presentations, but it's much more likely that it's just going to go out as a YouTube link that you can consume in your own time rather than as a scheduled event like this. I mean, don't get me wrong, this worked well, but as I'm out traveling, as I have been this week, one of our more common requests is to just have more stuff on YouTube. So I'm going to take this format of trying to put in 20 to 30-minute informational snippets of Z-band or just industry information into presentations. Hopefully, if we're taking the time to put them on YouTube, we can spice up the graphics a little bit, make them a little more compelling to look at rather than my art design. I do like to tell people I'm one of the 5 least artistic people you will ever meet. So the fact that I've been the one doing the slideshows and the graphics will hopefully be able to spice them up a little bit as we move into 2024. And it's just incredibly strange that I'm saying that already. But I'm going to get going. I just want to say thanks to everyone for coming. Several of you have been on, I think all 12 of these are Wednesday webinars as we've wrapped up each month throughout the year. This one I do expect to be on the shorter side. It's building off of everything that we've talked about previously over the last 3 months, mostly, as we've talked about video on demand architectures and DOCSIS architectures and uh, reverse path fiber designs for the ZHCs and all those kind of things. This one is just going to be the capstone on top of all of that. And that is then overview of the Balluns themselves and the piece that goes behind the TV. Several of you that I see on the call are existing Z-band clients, and the first thing that you're going to notice is that your Balluns don't look like this. This is a complete change in form factor and change in product that I think we first actually released. I want to say late 2021, early 2022. I apologize, I don't have that exact timeline right in front of me. And we did a couple of different things, and really the major purpose behind the redesign in the Ballun was to isolate a lot of the electrical signals. We wanted discrete paths for IR and RS-232 and data and those types of things within the Ballun PCB, rather than a lot of those sharing some legs and some other things that they had done on previous designs that worked great in terms of the RF side of things, but were a little more problematic if you ever wanted to, let's say, pass data and RS-232 controls over the same Ballun. There were some design limitations in the previous iterations of the device that we changed. So, and anything that you buy from us now, I say anything post the start of 2022, this is most likely the form factor of the Ballun that you're going to see. And a couple of other things that you'll notice as you are long-term Z-band customers is, go back. Laser point. The A button, B button. Those of you that have been with us throughout the year are aware of this. Those of you who are new to Z-band, the Ballun sits at the end of the TV system directly behind the television or monitor and provides coax out to the TV. What it does through the ZBTV input port here is actually accepts all that incoming RF video, all of that TV services, and also accepts its power on pins 7 and 8 of the category cable that gets plugged into this port. It uses an algorithm that's built into the Ballun to read that power, measure the millivolt loss, and then make an estimation of how far away the Ballun is from the ZHC that is providing it with signal. And then these LEDs kick into one of 5 different distance buckets, depending on how far away the UNV Ballun believes that it is from the ZHC. Now, you keep saying, notice that it keeps saying believes that it is. Assuming that the cable is run well and terminated well, and there's no breaks or intermittent patches or issues or anything that we know about, those algorithms are pretty reliable, right? How cable is manufactured is pretty reliable. There are standards that define all of that, tightness of twist, that type of stuff. So these algorithms can be pretty dialed in a standard environment. It is capable of being tricked if you have broken cable that's like showing more loss than what we would expect, if there's bad patching, those types of things. So these buckets can be fooled if for whatever reason the infrastructure isn't giving it the feedback that it thinks it should be getting. These A and B buttons, to kind of tie all of this together, do allow you to move the balun in and out of different bins if you think that, hey, this is wrong, right? So I'm just going to take, because I have a bright red laser pointer on the screen, this one as an example. The first bucket that the balun has is bin 1, red LED. That tells us red LED is anything shorter than 20 meters from the telecom closet, and it tells the balun that it needs to attenuate that signal. If you, as the technician, are out and about and you're looking at everything and you say, oh, red LED on this balun, but I know for sure that this one's 60 meters down the hall, there's something going on here, you then have the ability to go in, coordinate with Z-Band. We have a little article to show you how exactly to do this, and use those A buttons, B buttons to move the bins around on the balun, which is not a feature that you had before with the balun at all. So in addition to the things I'm going to show you today with the UNV X and XS balun, there are just some basic functional changes to the new generation of balun that I don't know that we ever actually introduced to everybody. And so I did want to cover those today at the beginning of the webinar, because like I said, this is not going to be um, a terribly long webinar based on some of the stuff that we're covering. So yeah, you can see the UNV balun, RF out to the tuner. And then the big difference between just the standard UNV balun and the UNVX and XS is those bidirectional return path capabilities. And I'm going to dive into that on the next slide. The other thing that I don't have on here, and it pertains to the next bullet of RS-232 commands, there is a serial number that is associated with each of these baluns now, and that serial number is readable by your distribution ZHC system. So to simplify that, if I connect this balun, and this balun is serial number 12345 to port 10 of a ZHC in my MDF, I can actually, using some software that we have now, query the front panel of that entire ZHC and read the serial numbers of the baluns in each room, which is, from our standpoint, from a monitoring and management standpoint, allows us to be able to associate, much like you would with a set-top box or a television, serial numbers to particular ports or points within the system, and then monitor that for changes. And really where that comes in handy from a Z-Band standpoint is with our Insight software and our monitoring software. I can read the serial number of this balun. 12345 is off of a ZHC in the MDF. 2 months later, I come back and I scan the system, or the system does one of its normal checks, and it flags. It says, oh, now balun 12345 is upstairs and it's on the 7th floor. That's probably not something to be worried about, but it is something that we want to flag in our system, because if people are moving baluns around, that means maybe they were doing some testing, troubleshooting, whatever, and we do want to be aware of what those things are on the front end, because it allows us to maybe diagnose some issues in real time rather than waiting for complete failure. So in addition to this RS-232 command to the television, there's also a serial number associated with each of these baluns, and that is useful for the RS-232 system, but also just in general for troubleshooting and troubleshooting with the Insight software, because that does allow you to kind of track some of those changes and set up a system a little more like you would be accustomed to with an AV over IP platform in terms of associating serial numbers with rooms and all that kind of fun stuff. For the rest of it, the communications, nothing's really changed from the previous iteration of the balun to the new iteration of balun. Again, to tie it back to the first slide, anybody that's familiar with Z-Band systems and has a Z-Band system that's more than 3 years old saw this and went, whoa, that looks a lot different than what I have. And the other thing that you'll notice here, I think it shows better on the other picture, is this is actually a screw-on case at this point in time. So there's definitely a little more security to the case of the Balun as well. So that's a little like quick overview of a couple of slides of what has changed with just the Balun in general. And now I'm going to get into the Balun XS, or yeah, the X and XS more specifically. And I'm going to start with the X. And I'm starting here with just kind of showing, this is a spec that I pulled off of Toner Cable's website. Full disclosure to the guys at Toner, all I did was went onto the website, searched broadband reverse path amplifier, and pulled the spec for the first one that I saw. Because what I'm about to talk about specifically with the UNV X Balun is this movement in the forward and reverse path frequencies as we transition from DOCSIS 3.0 to 3.1 to 4.0 to whatever comes as the DOCSIS standard keeps iterating. Because I'm going to talk about how we support the bidirectionality of that standard and how the movement of the reverse path frequencies within that standard have affected what we can and can't do in the Balun. And I feel like a lot of the times that I'm describing these issues, and I'm describing them through the prism of how they've affected Z-band or how they've affected a specific product within the Z-band family, I sometimes miss the forest through the trees and forget to tell people that, like, hey, this affects just more than just Z-band. And so as I'm going through and talking about the reverse path communications on the Balun and the Balun UNVX specifically, please keep in mind that this reverse path change that's taking place that I'm talking about is not only the Z-band system. This is any RF amplifier in your infrastructure or in North American infrastructure, whatever. As we're making this transition from DOCSIS 3.0 to 3.1 to 4.0, every RF amp gets swapped out, right? It's just, that is just the way it is, because we're moving our reverse path frequencies and our forward path frequencies. You can see here the reverse path moved up higher, the forward path moved up higher, the low end of the forward path moved up higher. So this is a thing that we are considering, and I'm presenting it through like the Z-band prism and how this works from the Z-band side of things. What I'm talking about when I'm talking about the next slide and these frequency changes, this is not unique to Z-band. This affects every device in a broadband infrastructure that is trying to send reverse path communications back to cable provider head end, right? And so to represent it in graphical form, this is what we were all kind of used to, right? This is traditional cable television. I've got 5 through 45 sitting down here as my T channels, my sub channels. And I don't know the age of everybody on the call. The easy one for this is, like, we used to do a ton of T channel modulation. This was broadcasting the crash cart back to the central modulator so that you could do morning announcements when you were in AV club in school. That's what all of these T channels were. Anything down below 54 megahertz basically is a sub channel. It's not in the forward path of cable broadcasting, it's in the reverse path of cable broadcasting. And that's where it lived for like the longest time until we got to the iterations here of DOCSIS 3.1. And you can see that my gray X slides up the scale, and we're no longer reverse path broadcasting just down here in 5 through 54. With DOCSIS 3.1, we can put our reverse path broadcasting all the way up to 204 megahertz. And then we go so much higher on the outbound RF frequency, where before we were kind of capped out even below 1,000 megahertz. Nothing was even really up above 750, 860 previously. To now with DOCSIS 3.1 and DOCSIS 4.0, your forward path communications are significantly higher. And the impact on this from a Z-band standpoint, just putting it straightforward, is like we just can't support cable set-top boxes that are DOCSIS 3.1 or higher. And there's two basic problems. The two basic problems are, number one, the forward path frequencies are too high. And this isn't a Z-band thing. This is a category cabling limitation. And I'm sure those of you who are troubleshooting our systems and have dealt with our systems over the years have noticed an incredible phenomenon that if you go too far from from the IDF, or you don't have enough power coming into your Z-band system, your high channels are the ones that you lose first, right? And that's not a thing of like Z-band design. We didn't think that the high channels were less important or anything like that. It is that the roll off of the frequency loss on category cable is exponential. To put it to some specific numbers, if we're broadcasting as Z-band on the bottom end of this frequency, 54 megahertz, and we want to go all the way to the end of a 100-meter run, we're going to lose about 20 dB at 54 megahertz at the end of that 20-meter run, roughly. If we're all the way up here at 860, where the top end of this TV spectrum used to be, you're going to lose 60 dB with some wiggle room there. Not a ton of wiggle room, but some wiggle room there at the top end of the spectrum. And it kind of hits a cliff in the 725, 750 range, where that roll off becomes just a lot more dramatic towards the top end of the spectrum. And again, that's not a Z-band thing. That's just loss over distance within category cabling. So as we're pushing stuff out here, and we're at a gig or 1.8 gig in our broadcast frequencies, we're just not going to be able to create enough power on the front end amplification to maintain decent, high quality video signal all the way up at this end of the frequency range. And so, with that being the case, we are very much limited to, at least when we're talking about traditional cable providers, head end based systems, right? Your Com 3000s, that was commissioning a system out in Texas today that's what they've got in on the head end. Your smart boxes from DirecTV, and then any of your bulk services from your cable providers and their partners, whether that partner is Vecima, ATX, Blonder Tongue, Drake. There's all kinds of boxes that are out there for QAM to IP or QAM to QAM roll off. So it does mean, from a Z-band standpoint, that this change and the loss of category cable, the loss over distance of category cable, means we are kind of stuck at only being able to support cable set-top boxes if they are of the older standard, because these newer standards have started to get into some frequencies that are problematic with category cable. So that being said, why would we have an entire webinar just to tell you what we can't do? Well, that wasn't really the point. What we do want to do, and especially with some of you that are on the call today, the primary use case that we have now as Z-band for reverse path systems has been supporting sonify patient engagement in reverse path systems in the healthcare industry. We've done a little bit of this in the hospitality industry, where we're getting into hotels and casinos and that kind of stuff, and worked with sonify systems and other communications systems, RS-232 control systems there as well. But at this point in time, primarily, if you are coming to Z-band and you're saying, hey, we need to do a reverse path system, this is the direction that we assume that you're going, because it is the reason for maintaining this product set was specifically for a couple of larger projects that we had where sonify systems were going in. And so really, as we're kind of here on this slide, I do want to answer kind of the fundamental question, which is, why does it matter what frequency the reverse path is going back on anyway? So within the balun itself, there's, for all of our reverse path baluns, there is a little device called a diplexer. And those diplexers are frequency specific as to which frequencies they're looking for reverse path communications or forward path communications. What that diplexer does is it basically just sits in the balun and keeps the reverse path closed the entire time that the system is operational, unless it hears a request coming from the television to go back and talk to the sonify system. In the sonify head end, in this example, is a good way to do it. And the reason for that is, if you keep that reverse path open all the time, you can get any noise that gets into the system, any noise that gets into that reverse path is just there, and is constantly there being looped into the system. So keeping the diplexer there on the front end does keep any noise, keeps any extraneous whatever from getting kicked back into the system, or for any messaging that's not supposed to be there from getting kicked back into the system. And again, to call back to kind of that first slide, this isn't unique to Z-band. This isn't a thing that's like only Z-band designs it this way in the industry. Any RF amplifier that you've got has this exact same issue where they have specific reverse path frequencies that they have hardware limitations because of the diplexer within them that defines what they can support. So I do want to make sure that I'm hitting on that, because I know a lot of you come to these webinars, and yes, we want to learn about Z-band, but I also want to make sure that we maybe can help you out in other places as well. And this is one of the places where we maybe can help you out. If you have cable set-top boxes throughout your infrastructure, at your house, at your dentist office, whatever, and they do a fiber plant upgrade, and all of a sudden your cable set-top box doesn't work, that's what happened, right? You can't communicate back on the reverse path frequency anymore, or there was some change in the CMTS. I mean, again, the cable company's normally pretty good about this stuff in telling you that you need a new set-top box, but there are times that we've seen it happen where just a box didn't get switched out because nobody knew it was there or whatever. So I did want to make sure, again, as I was kind of going through this, that yes, there are some specific Z-band design criteria here, but there are also just kind of in general more industry things that you should know. We're working with a healthcare facility right now in the Mid Atlantic, and they're going through an upgrade, and what they're finding, they're losing channels because of to go all the way back to the beginning, not the backward path, but the forward path. In the days of too far, these TV signals, some of you designed systems, some of our clients designed TV systems where this was the only frequency spectrum that mattered. And the frequency spectrum that mattered to you at that point in time stopped at the end of these green triangles, which is about 550 megahertz, right? That was the channels 2 through 78 days of TV. That was when TV didn't go higher than 78. That was the end of it here, right at these green triangles. So that client has been finding out as they've been going through, not only do they have potentially to reverse amplify, to change out amplifiers for reverse path communications, but their forward path just doesn't go up high enough. They haven't swapped out amps since the channel 2 through 78 days. And so now they need to go through and redo that entire infrastructure. So I did want to make sure that I kind of rounded this off with this diplexer, and the UNV-X, UNV-XS is a Z-band thing, but it is also very much something that every RF amplifier in the industry is subject to as well, if you're using these things in a system where the frequencies are soon going to be changing. The last thing to touch on here as I kind of slide through and open it up for any questions to go in the chat. The UNV-X, UNV-XS Balins, all of the new UNV Balins that Z-band has produced are backwards compatible all the way through your Gen 3 systems. So, and the biggest differentiation between Gen 2 systems, which we stopped producing in about 2011, all the way up through the systems that we have now, is for us, Gen 2 and Gen 3 was the dividing line between active and passive systems. Anything after Generation 2 was an active system where the Balin has an algorithm in it to do that distance adjustment I talked about at the front end of the webinar. Anything prior to that, it was simply a high pass or a low pass Balin. So it is backwards compatible. The new UNV Balins, UNV is universal in our heads at least. Is compatible. The UNV Balin is compatible with basically any active Z-band system that's out there. So if you do have a 3, 5, 7-year-old system that's using Sonify and you need to add some TVs, the UNV XS Balin is your go-to. And yeah, with that, I'm gonna wrap it up right about 25 minutes and a little overview on kind of DOCSIS infrastructure and how reverse path communications are impacting not only us, but a little bit of the industry in general. So if you have any questions, please feel free to put them in the chat or the Q&A, and I'll give everybody a minute or two to do that. If not, I hope you guys have a wonderful holiday season, safe travel back home if that's what you need to do like me to round out this week. And then, yeah, have a great new year, and we will talk to you again in 2024. So I'll sit here for a minute see if there's any questions pop in. All right, everybody. See a couple of people started to drop off. No questions in the chat. No questions in the Q&A. Thank you guys very much for attending. I appreciate everyone that stopped by and spent a little bit of time with us this year. Happy New Year, and we'll talk to y'all soon. Thank you.